So hello, welcome everyone. Welcome to the Pi and AI Pune, building your own DL library in JavaScript, hosted by DevScholar. And I'm here with Suyash Sonawane. Suyash, can you go on to the next slide? So
Everything is okay.
what is Pi and AI? First of all, Pi and AI is a series of DeepLearning.AI meetups independently hosted by community groups. Event typically includes conversations with leaders in the world, thought-provoking experiences, and we talk with everyone. Last time we have Sayam Bhutani. He told us about his experiences and everything. And this session today is kind of a hands-on, you can say. Like you can see what we have built or the speaker has built and go accordingly. So today, for before starting it, let's see. Here is a short greeting message from Andrew and his team at DeepLearning.AI.
Hello, Deep Learners. I'm Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on the batch?
How much is going on in this field? There is never a dull moment. You know, you might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the DeepLearning.AI community.
So this was a short message from Andrew and his team. Thanks a lot, DeepLearning.AI team, for partnering with us and letting us host a event at this scale. And now the speaker, Suyash Sonawane, is with us, the DSC PCCoE lead, and currently AI research intern at CDAC. He is also the webmaster at PCCoE ACM student chapter. And let's hear about him through himself only, and then he'll continue the session. Suyash,
So
it's all yours.
yes,
Yeah.
thank you, Tejas. Am I audible?
Yes, clear.
Okay, so hi guys, I am Suyash Sonawane. I am DSC lead at PCCoE and also research intern at CDAC. So today we will be going through 2-3 topics. Just a second, I'll just share my screen. Hello guys, am I visible?
Yeah, you're busy.
Yes, just a second, let me just escape.
Yeah, by the time he sets up, guys, just one thing. In the chat, please let us know from which year you are, like TE, SEB, FE. Like, I don't think we have FE, but just type in the chat box so we know who is the target audience. Thanks.
Okay, so are the contents visible?
Yes, Vish.
Okay, so first of all, we will dive into the basics of neural networks. Then we will check how we can write a JavaScript library. Then we will dive right into the code. Then we will check the demo of how our library is functioning. And then we will discuss how we can add more features and how you can host your like the mini library or the script file, and can everyone can easily access your files. And then we will wrap things up. So first of all, let's dive into how basic neural network functions. So before going into the session, I have a quick question for you guys. How many of you already know how neural network functions internally? So you can give them in chats. Like, I know, I know. Wait, I can't see your chat, by the way.
There's a bit lag in the chat and the video on YouTube and okay, I guess we should continue.
Okay, so first of all, let's consider a neural networks as a box. Like we have a box in here. Okay, so we have a black box in here, and here is our neural network. Then here we have our input, and then we give this input to our neural network, and it gives us an output. So the input can be anything like images, audio, or anything, but it should be in numerical format, that it should be a float or integers. And at the output, it will give a prediction of whatever we want it to give. Okay, so let's dive into what exactly happens inside a neural network. So suppose I enlarge this in here. Then here, what we can think, we have these input nodes, and then we have a hidden node in here. And at the end, it's not circle, it will be something like this. And then we have a output nodes in here. So the input nodes take the data from outside and then give it to the hidden layers or the hidden nodes, and then they process, and then it gives the output to the output node, and then finally we get the result in here. in this state. Okay, so it is a computational model. In easy layman terms, the neural network is just a computational or mathematical model. It takes the input x, it multiplies it with the weights. We will go right, like what is weight and what are biases. It multiplies it with weight and then add the bias. So this function takes place at every node, and then we apply activation. Suppose we have this activation function, then it applies the activation function, and after that we get some value. Okay, so where does this all thing happen? So these all things happen inside a neuron. So you can consider neuron as the smallest computational unit. Here you have activation function, suppose a, then we have the weights and all those things. Okay, so you can consider this. Okay, so here we have the weights, and the weights are of type matrix. Okay, so they are some matrices, and then we have this input. So this is also in the form of matrix, and we multiply them, and then we add a bias in here. So also a bias is also added. So we add a bias which is just a single column. Okay, so after that we get output matrix, which is of some values like z, z, z everywhere, and then we apply an activation function in here, and after that activation we get this output. Suppose for that we will consider this as a. This a and this a is okay. So now what we will do before creating a neural network, first we need to create matrices which can handle all these functions. So beforehand I have created this plain template. So what is this? This is just an index.html file. Here we have a neural network.js in which we will write our code for the library. And here we have the main.js, which will just create the instance of our class and then do the stuff. Okay, so first hand, let's create a class matrix. So, okay, here we have matrix. Before that, let me just pick out this thing. Okay, so we went over this basic thing. Now, what is and how to write a JS library? So before writing directly a JS library, what we can think, a library is like just a class or a functions which are pre-written in most optimized way, and the user who is actually using the library or the developer, they can just initialize the class and use the functions. So what we can do, we can create a class and we will expose the functions through that class. So for that, first we require a matrix class, then we require a neural network class, and here we will do all the functions. So the matrix class is a bit lengthy, it is around 100 or so lines, so we will not look more into that, but we will work more in the neural network part. So I have already written that part. Let me just take it from here, but I will just go through of what is inside the matrix class. Okay, so I guess you can read my code. Tejas, is my code readable? Like the font is
Yeah,
proper?
it's legible. Yeah.
Okay, so you can see like the matrix class has a constructor, and we pass it the number of rows and the columns we need for the matrix, and then it has this array called data. And what we do, we initialize the whole array with zeros, or the whole matrix with zeros, and then we have these member functions. So these functions can be directly called, like as you can see, we have a static keyword in here. So we can directly call these functions from this class without creating an object. Okay, so these are helpful when we need to return new objects. So as you can see, we are returning something and not changing the actual data of this object. So then we have this subtract, that will just subtract the contents of two arrays. You can see they are just bunch of for loops, and here we are subtracting the data of A minus data of B. Then we have to array and from array. So the from array function is used to generate a matrix from a single array. So what it will do, it will take an array and it will convert it into a new matrix. So suppose M, and it will return that matrix. And the toArray function does the opposite. It will convert the matrix into an array, and it will return an array. So then we have this randomize function. So what this randomize function do? It will randomize the values of the current object. So you can argue that we can, while doing initialization only, we can randomize the values. But it might happen you might need to randomize the value later in your code. So there, rather doing it there, we can just write a simple function and it will do that. So now we have this add function. Now here you can see I have this keyword instance of. So the add function can take a scalar or a matrix. So we need to check first, like is the past variable a matrix or just a number. So what we can do, we can just check this, and if it is a matrix, then we can add that value like element wise addition. And if it is just a scalar, then we can just add the scalar to every element of the matrix. Then we have this transpose function. It will just, as it says, calculate the transpose and will return the new matrix. As you can see, we have static here, and it is returning the new matrix. Then we have the multiply function. It will do just the multiplication. Like here, you can see we are doing the dot product of the values. And then we have this multiply, which is hammered product. So what is this use? We use this to just scale the values of the matrix, and we can just multiply it with scalar. It will also scale the values. Now we have this map function. So the map function is used to apply a certain function to all the elements of the matrix. So you can see we are just going through all the elements and just applying the function which is passed in this map function to every element. Okay, and then we have the static variation of the same function to just return a new result. Okay, and then at the end we have this console.table to just the print out in the matrix in pretty form. So I will show you how this matrix library work. Go live in here. I guess it will open in somewhere. Okay, it opened it there. Just let me bring the window down. Okay. So this is the plain HTML part, and now we will go into console. Just clear out the console. Now you can see we have access to this matrix class. And if we just, you can see we have this matrix class. Now I will create a new matrix. Suppose let new matrix, and I will pass it the value of rows and columns. Suppose 3, 3. Then you can see we have created this matrix. It contains this information, the data array, and in array you can see we have zeros. Now what I can do just randomize it, and see we have also access to the functions. Randomize. Now you can see it is not returning anything. It is just doing the calculation on the array itself. So what you can do, you can just print it. And yes, we can now see we have this table, and in this the elements are randomized. Yes, also I need to mention this thing. While randomizing things, what we have done is we are randomizing between -1 to 1, so that all the data is centered between the mean of 0. Okay, so here you can see we are doing this by using this simple trick. What we are doing, math.random gives us a random number between 0 to 1, and we are scaling it by 2 and then subtracting 1. What this will do, this will always generate a number which is in between -1 to 1. So you can see we have all the values which are between -1 to 1. Okay, so I guess now, yes, I will just show how the static function works. So let me just clear out the console. Suppose now I need to have a transpose of this matrix. So I have this matrix MM. So there is no transpose function to this, but I need to make a transpose. So what I will do, I will go to the class matrix dot, and then I will access the static function transpose, and I will pass it that matrix. Now here you can see it creates a new matrix with the transpose. So if you check, now there is no way to check this. But Yes, I can see the transpose. Wait a second. Okay, it's symmetric, I guess. Okay, so let's move on further and dive into our matrix class or neural network class. Okay, so for the neural network class, as you have seen, we need a constructor to initialize the values. So for that, what we will do, we will just write a constructor in here. The constructor, it will take the shape of the input, like as I shown here. What we need the shape of the input, as we need to generate a matrix for that. So first we will ask the user, like just input the shape of this matrix, then input the shape of this hidden matrix, and then input the shape of the output. Okay, now what we'll do, we'll like I shape, input shape, then hidden shape, and then output shape. Okay, so now we have these functions in our variable. Let's go down just a second. Okay, so now what we will do, we will create a matrix from these shapes. So for that, I will create a hidden matrix. For first of all, I need to do some things in here. Okay, so now we need weights. Okay, so what are weights? Weights are nothing but just a matrix with random values initially. So what we will create two weights, as we have three layers. Okay, so the weights work in this fashion. Suppose I have this hidden layer and this input layer and this output layer. Okay, now here are some connections. So these connections are called as synapse or synapses. So these synapses have weights in them. So suppose this is weight W1, this is W0. Okay. Now the weights are then multiplied to the input which we gave. Suppose we gave input X, and then the weights are multiplied and then they are passed further. Also, a bias is also added here, because it may happen that the weight is initialized to 0. And if we multiply 0 with just input anything, then the output will be always 0. So to solve that issue, we also add a bias. So now moving on forward, we will create a weights array or the weights matrix. So we need two weights. So for that, what I will do weight 1, or just more intuitive, I will give weight underscore input and output. And for that, we will create a new matrix. And we will now pass the shape. So first we need to pass the shape of each array. So this is the shape. Then I will just copy paste the same command, as we need to do this 2 times. Then I will create the same for same for the output and hidden weights. So for that, we have here the output shape and the hidden shape. Okay, so now we have the weights initialized, but now we need to randomize these weights also. So what I will do, I will just call the function on the weights dot randomize. Okay, so now the weights are initialized and randomized. Okay, so now what we will do, we will do the same with the biases also. So for the bias, what we will do, we will create two bias. That is bias for the hidden layer. It will be a new matrix with the shape of hidden and just a single column. Then this dot bias hidden not output. It will be new matrix with output shape and just a single column. Now we will also randomize this. Okay, so now we have initialized and randomized the weights also. Now for the future purposes, we need a variable called learning rate. So the learning rate we can pass in the constructor also, or we can pass in the fit function also, which we will look forward. Rather than I will just statically define the learning rating here. It will be suppose like 0.1. We will talk about the learning rate in future. So let's try our library of how it functions. Now I guess we can have access to this class neural network, and you can see we can pass this shape here like input shape. Suppose I will give 2, then hidden is also 2 and the output also 2. Hit enter. Now you can see we have this new object. It is created. The biases are of shape 2 1. Then we have weights also. There's also 2 into 2 because of this format, and they are also initialized randomly. Great. So now what we'll do, now we'll talk about the forward pass. So for that, I will go into here. Okay, so now what is a forward pass? So for that, I have this quick GIF, what do you say? Okay, here you can see we have a sample neural network, and we pass the variables to the input nodes. Then the input is then multiplied by the weights in the snaps, and then we add bias to them, and then this process continues till the output layer. So this is called the forward pass, and at the end the output is then given as a prediction. So what we can do here, we will just create a predict function which will do the forward pass for us. So for that, we will take input as x, the first initial input, these variables, and it will be an array, suppose. Okay, so x, the capital X will be an array, but we need a matrix. So for that, we have from array function. So what we will do, we will create x, small x here, and new, not new, we will create matrix dot from array. It's capital X. Okay, so now we have the array converted into matrix format. And now what we will do, we will do the computations. So for that, I will create a hidden variable, like suppose hidden here. And what I will do, I will multiply it with this weights of hidden and output weights, and with the this input x. Okay, so now the value will be stored in this, and we will create a new matrix, as this is the static function on the matrix class. So further, now what we'll do, we will add hidden L, we will add the bias. So we already have the bias for hidden layer, that is hidden bias edge. And then what we will do, we will apply the activation. So now we have new word called activation. So what is the activation? Yes, so the neural networks, what are neural networks? They are just functions. Okay, so if we have functions, a function called x plus y, then this is just a linear function. Okay, but when we add some power or anything, we can the graph can trace out a curve. But mostly, if the function is linear, we have just straight lines like this. But suppose we have the data set, which is suppose we have these classes. And in this class, we need to classify. Suppose we have here A, these are all A's, and these are all B's. So we can linearly classify by using just a line. Now we have separated the class. But suppose there is more complex, and we have something like this, and it is more complex, and we have multiple classes. So by just drawing a straight line, we cannot classify them. So what we can do, we can draw a curve like this. Suppose like this is a one class and this is a one class. So for that, to make the line curve, what we can add activations that are non-linear. So the non-linear, they can fold the space around the points. Okay. So for that, there are various activations. So what we will do, we will just use a simple activation called sigmoid. So what sigmoid does, sigmoid is something like this. So it maps the values between 0 to 1. So it is also used for calculating the probability. So we can use that easily in here. So I will create a function like this, the function sigmoid. Okay, the sigmoid, it will take x and it will return the calculated sigmoid. So do you guys know the formula of sigmoid? Like, does anyone know the formula? Tejas?
Yeah. Hello.
Do we have any comments in YouTube? Like,
Other than Suyash OP, like there is a lag, so let's wait.
okay, let's wait for a second.
Yeah.
So I guess okay, we will check the comments later. Okay, so we will just return this sigmoid. So this is the formula for sigmoid: 1/1 plus exponent like e raised to and then the minus of x. Okay, so this is the formula for sigmoid, and for future references we also need a derivative of sigmoid. So what I will just call it as d sigmoid, and I will pass suppose the y, and we will, the derivative of sigmoid is simply calculated as y into 1 minus y. Okay, so this is the derivative of sigmoid. We will need the derivative in future for calculating the gradients for backward propagation. Okay, so what I will do, I will just apply the sigmoid function to every element of the hidden layer matrix. So for that we have a map function in hidden layer like the matrix. So we will map the sigmoid. Okay, now it is done. Now I will create output. This is for the output layer. Underscore L, and then matrix. Now here you can see we are doing this same like what we did for the hidden layer, we are doing same for the output layer also. I'll just copy, paste it here, and I'll just change this to output, and here the weights will be of hidden and output layer, and the input will be the previous calculations of the hidden layer. Then we will add output 1, and then we will add the bias of the output layer. Then we will map the sigmoid to the output layer. Okay, now we have this, and now at the end what we will do, we will return an array of the predictions. So we will call the toArray function, which will convert the matrix to the array. Okay, so now I guess we can calculate the forward pass. So I will go to our, and I will create a new neural network. We already have this 2 to 2 2. I just make it 1, and here we have neural network, and then nn dot predict. So now we have this function predict, and we can pass in the array of shape 2. So I will just pass 1 comma 1, and you can see we get the output. So the output is in the shape of this what we pass in here. So suppose I pass 5 in here, and then I call this, then you can see we got 5 values, and these are just random because we haven't trained the neural network and haven't shown the data anything. So these are just a simple forward pass. So what now we will do, we will create the train function. Okay, so for that we will create a train function, and the train function will have x and y. Okay, so these are the data points in our data set. So we will do similar. First we need to do a forward pass. So I will just copy this thing as it is just same. And okay, so we have this. Rather than creating new, I will just reuse the variable. And just change this x to capital X. And here we need again we need to map, I guess. Okay. Now we have the forward pass. Now we will talk about the backward propagation or the backward pass. So the backward pass is also very similar to the forward pass. What we do in the backward pass is, suppose we have these neurons, like the small computational units, and then we have this output neuron, and here are the connections or the synapse. Now the forward pass calculates in this direction, so the backward pass will calculate in this direction. So in this we are multiplying it with the weights, and in backward pass we are multiplying it with the gradients. So what are the gradients? So gradients are used for optimizing the weights. What is optimizing the weights? So suppose optimizing the weights is like we need to adjust the weights so that the output will match the expected output. So while training the neural network, we also give it the input and the output associated with that input. So suppose the photo of a cat and the label of cat. So the label can be 0 for cat and 1 for dog, like that. Okay.
We
So
have a
what we can
question.
do in here? Okay.
One question. In train function, why are we copying the code rather than calling the function?
Okay, because in here we are returning the output array. So what we can do, like we can return the output array and then convert it again to the array, again to the matrix. Then we have to call this also, like we need to call, if we need to do that, what we can do, we can do predict, this dot predict and pass the x in here. And then we need to again do x dot matrix dot from array. So this is the alternative of what we can do.
Okay, so the return type is different, right?
Yep. So for actually this function is used, this is exposed to the user to predict the values. But we are, as the predicting values and the forward pass are same, so we can just reuse the code or just call the function internally. It doesn't matter. So we can also call this function. So no problem. Okay, so where I was, okay. So now what we are going to do, we have the output of the forward pass. Suppose we have this array and it has some 0.123. Okay, but actually the output should be 0.54, suppose. So now there is an error. Okay, so what we can do, we can subtract and check how much was the error, and we will tell this in neuron that there was an error and this was the value. Then it will change its weights, like the weights in here, and this error will be passed backward to all the neurons in the neural network. Okay, so then now the error back propagates. So this is why the name back propagation. Okay, so we can do this very easily. This trick is called, we can use a method called a gradient descent for this. So what gradient descent is, suppose we have a cost function. What is a cost function? So cost function is just like a function which takes in the error and just maps a graph to it. Which is the cost? Suppose we have a cost function which is like this. So this is actually the error, and in here, suppose our current state is in here and we have this much error. Now we need to minimize the error. So for that, what we can do, we can just change our state to here, but we can just magically disappear from here and go to this state. So what we can do for that, we will just minorly adjust our weights and we will slowly go in this direction, in downward direction. But but we can see that this is the direction in which we should go, but the calculations are not like they can see the values. So for that, we can calculate the gradient. Now what is gradient? It is just like a slope. So like slope and gradient are the same things. So we will calculate the gradient at this point and we will just check like, okay, we have the low gradient in here, so we will go in this step. So we will just make a hop in here. So now the part of learning rate comes in. So what is learning rate? It is the distance of this hop. Okay, so what you can do, you can just take small steps to get till here, like 1 hop, 2 hop, like this. Or you can, what you can do, you can directly take a big hop from here to here. But you can't always guarantee that the hop will end in here. Suppose you take just a giant hop till here, then you go here. Then what you can see, the gradient descent tells you to go in backward direction. So you will hop in here, but the jump is also same, like from here to. So you will go and jump in here, then you will do it again, then you will do this, then you will keep on hopping from here to here, but you will never reach the minimum of the cost function. So for that we can set the learning rate to low or small value, so that it will be hopping like small, and at the end we will get to the lowest point of the cost function. Yes, so we can implement this using gradient descent. So now what we will do, we will implement the gradient descent algorithm. Okay, so for that we have a target. So for target, it is the actual value which is supposed to be the output of the neural network. So it will be this y that we passed, the y data point. Now it will also be an array. So we will convert it from array, then y. Okay, and then we will calculate the error. So for the error, this will be output. This will be the error of the output layer. Okay, so we will create the output error variable and we will subtract it. So here matrix dot subtract, as we need to create a new matrix. So matrix dot subtract the output. Now here we don't know, we have x minus target. So what will happen? The values of these two matrices will be subtracted and a new matrix will be generated, which will be stored in the output error. Now we will calculate the gradient. So for that, I will just add grads for gradient. So for those who have already tried out such things in PyTorch, you can see it is a similar flow to PyTorch, in which we have a gradient, then we have optimizer, then we step the optimizer, and it is similar to that thing. Okay, so now,
Suyash,
so now what I will do?
can we have another question?
Yes, yes.
So the another question is, if the learning is slow, then we will also need more data, right?
No,
Is that the
actually,
case?
learning, no, learning is not slow. You need to feed the data again and again, the same data. But if you feed the data again and again, then you will overfit eventually.
Yeah.
Actually, the learning rate is something called a hyperparameter. So you need to tune the hyperparameter. If you change the learning rate slightly, your like suppose your learning rate was 0.01 and you changed it to 0.02, then also it might make a big difference in the training process, as it is the gradients are calculated at every layer and again and again and again. So they accumulate a huge cost. So now what we'll do, we will map the derivative of sigmoid to calculate the gradients of the weights. So for that, what I will do, I will just map the output. What I do? In this, we don't have output, we have x, and we will map it to the d sigmoid function. Okay, here we have the gradients, and now, okay, now we will multiply the gradient with the error which was generated in the last layer, and then the gradients we will multiply it with the learning rate. So like this dot learning rate. Now we have the gradients for our last layer. Now what we have the gradients. Okay, so now we need to calculate how much we need to jump, or how much we need to change the weights of the last layer or the hidden output layer. Okay, so for that we will calculate delta. Now what is delta? It is just a change we need to do in the weights of those layers. Okay, so for that I will just create a new variable called hidden delta, and we will matrix. Actually, this is all mathematical part. So if you want, we can just provide you the links and you can go through them, as these topics can get very much advanced. Like you need to know some calculus to deal with that. So we'll just pass the gradients, that will take the transpose. What I'm doing, we'll do the matrix dot transpose. Just a second. Okay, so I just came across something. Actually, we can't do this in here because we need access to these layers. If we just take out this variable from this function, then we cannot access these layers in here. And for back propagation, we need those. So for that, we cannot use this this method in here. So let me just remove them. Okay, so now we have access to this hidden layer because we need to calculate the delta for that layer. Okay, so now I just check hidden delta. Okay, now we'll do hidden. Okay, now it will function. Now what I will do, I will just add the weights of this HO dot add this delta that we calculated, and at the end we will also add the biases. Like the biases also need to be changed, the last layer, and we will directly add the gradients to them. We are done. Now we did this for the last layer. Where is the last layer? Okay, so we did this for this last layer. Now we also need to do the same thing for this in between layers. Okay, so for that I will do just copy paste. No, rather than copy pasting, we will just write them because it will be just a practice. Or no, we have less time. So let me just copy paste them. Okay, here you can see I duplicated the code, and here we just have the hidden errors. Now to calculate the hidden errors, what we can do, we cannot use the last output of the layer. For that we have another method in which we will multiply the errors which was given by the last layer. Okay, so it is like something like you and your friend, like your friend is behind you and he tells you something to that you can tell to someone who is standing in front of you. Then he says like, no, this is wrong. So what you will do, you will self correct, like you will correct yourself, and also you will tell your friend like you did this wrong, so you need to change these things. So we are propagating the error backward. So we can do this by multiplying the transpose. So multiply, and we need to take the transpose of the weights of the hidden layer, a hidden output layer. So these are the weights of hidden output, and then we need to multiply it with the error. Okay, so now I have the error of the hidden layer. Now what we will do, we will simply again calculate the sigmoid, like the derivative, the sigmoid, and we have what I'm writing, h dot error. Then we have the new grades, so it is also recalculated, so there is no need to create this. Now we will multiply the error. We'll create already. Okay. So we need to again multiply the error and then multiply the learning rate. Then we will change this to this weights dot ih. We will add this hidden delta. So this is the hidden delta will be changed, and l dot l output transpose of output layer. Okay. The x which was final input to our this, and input data. Okay, hidden delta adding okay in here h. Okay, so now what we have done, we suppose here we have these neurons and these neurons. So suppose this is layer 0 and this is layer 1. Now this can calculate the errors directly from the target labels. But in this layer, we do not have access to these directly labels. So what we will do, we will calculate the error with respect to this layer. So for that, we can multiply the error of this by the weights of this. So we will get that error. So what we have done that in here, and then easily we can calculate the gradients by using the derivative of sigmoid. Then we multiply the gradients with the error rate and then the learning rate, not error rate, actually the error. So then we will calculate the delta, that the change we need to make into the weights, and then we will add the change into the weights and then the gradients into the bias. And now by doing this, we have finished our train function. Now the weights will be updated, I guess. And now we can't actually test this train function directly. We need to make a fit function which will internally call this train function again and again. So for that, let's create a fit function first. So the fit function will also take x and y, but this time the x and y's are actually the whole data set. And also the fit function will take epochs. So epoch or epochs. So epochs are like how many times you need to iterate over the data or like go through the data. So we will just make a for loop in here. Actually, you need to vectorize these things so that we are not we are not calculating same things again and again. So for that you can use NumPy or like these functions in Python. But for JavaScript and our small library, we can just use the for loops over and over. So we will just the epochs again and again. Okay. And here what we will do, we will call the train function. So this dot train, and we will pass x the samples. Okay, so you can see I am not passing whole data set but just the samples. Now to get the samples, we can randomly choose what samples to what samples should go into the train step. So for that, I will create a sample variable which will be a random number. So random into the length of x, suppose x dot length. Okay, and also we need to convert it into integer. So for that, I will just use mat.floor. Okay, so now we have them here, and we will pass only that single sample for a train step. Okay, so now we can test our neural network. Let me check if there is any error. Okay, so no error. So what we can do, we can initialize that in here. Suppose I will create an NN, then new neural network with input of 2, hidden layer of 3, and output of 1. Okay, and we have this x. Suppose it will be an array. For sample, I will create a XOR table. So in XOR, I can say 0 0, then 1 0. 1 comma 1. Okay, so we have this in here. Now, as you know, for XOR, if the is same, if it is same, we get 0, and if it is different, we get 1. So this, I just create this thing. We have, okay, so we have this x and y. So what we will do, we will call the fit function. We will pass this x, we'll pass this y, and we will fit it around, suppose 50 times. And now it is fitting. Is there any error? So I guess cannot read property 0 of undefined. Train the same shape. Let me check what is the error. 001 t dot add I0. Created I dot add. I guess there is some issue. Let me check a minute. Passing here. Okay, so the columns are not matching. Okay, we have here 3, then 2, then 1. This might be because of sample. Okay, no, it is correct. Small max x. Okay, the issue you can see, we change the variables. So in here we have x, capital X, but we are accessing small x in here. So that we need to change. And now we have another error. So uncaught cannot read 0 of undefined, subtract, train, capital X, target. Okay. Second. No, actually we are doing it another way. Don't need to do it like this. We need to pass the output in here. Just let me check 1 second.
We have a comment in the chat. The matrix is 2 comma 2 comma 1. Maybe that's why.
Wait, what? Here.
Yeah, in the chat they're saying.
No, actually this is the hidden layer, so this might not make a difference. I guess we can use the debugger to help us. So you can also take a look how we can debug up JavaScript code. Okay, so now the execution is paused and we now we can access the variables. So now we just step from next to this grammar check. The time, okay, we also have time constraint. I'm sorry. It is not going into train. Okay, I need to call the debugger there. Okay. In sigmoid, okay, sigmoid is just a function. Now we have array of output. Then we have from array, this works. So we actually have this problem in here, array of y. We find target output, target has this one, okay, correct. Then we have this output, which is something different. Then we have this. Okay, we now map the sigmoid. We have this, which is gradient is undefined. So the problem is in this, I think we have this thing, the d sigmoid. Okay, now the gradient is defined. Now we have the gradients. Okay. So rather than debugging, I guess I have the sample code in here. I will just copy paste. So to avoid time constraint, as we already have passed around 12. So second, I guess this should work now. No, we still are getting property of 0 defined. Wait a second. Let me now just check what we are doing in here. I'm just taking the sample x, y. We will passing this and y 0. This cannot read calls of undefined. Okay, I guess there was some error in, I don't know where the error was actually. Okay, so what I can do, I think I'll provide you the code as the main function of how we actually write the library and how the functions work is clear. But I guess there was some error in this thing, subtract and output. I will just check and I will let you know on Discord or anything. So moving on forward, so we have done this. Okay, I need to find. Now we need to do a code review and a demo also. So for that, the code review, you can see we have this train function, which is internally called inside a fit function for n epochs. And then we take a random sample and just pass it to the train function. Okay. So now we will go to the demo. So for that, I have created this simple dataset. So that this dataset is actually contains small samples. So here you can see it is just checking the center number. So suppose we have these three numbers and the center is 0. The center is here, the value is 0. Then for 1, 1, 1, 1, 0, 0. And we are fitting it 5,000 times. Okay. And then we are checking the output. And it is saying 0.04. So we have two classes here, 0 and 1. So if the value is less than 0.5, then the label is 0. And if the value is greater than 0.5, then the label is 1. Okay, so that's we get as the end result of the sigmoid function. It is maps the value between 0 to 1. Okay, so if we change the center value to 1, then you can see it gets high 0.96, so it is close to 1 and also greater than 0.5. Next, I have a small demo for you to show how actually this works. Let me just comment this thing. And here. So suppose we have some random samples, and the random samples have 3 values, and we need to find which one is the minimum of them. Okay, so for that we can just easily write a if condition and check which is the minimum. But what we will do, we will just try with it our new neural network library. So I will check and it is not defined. For that we need to generate this. The 2 to 5, I guess, no. Where is it? For that, n equal to new neural network, and the input will be of shape 3, then the hidden layer will be of around shape 5, and the output will be 1. So the output also will be 3, sorry. And here you can see we have these values, but what do they signify? So you can see that we are predicting the minimum of this. So the minimum is at index 1. Okay, now you can see the value for index 1 is 0.94. So it is saying that the index 1 is minimum or has the highest probability that satisfies the condition. So that's all. And also this is just a sample small library, and it contains the minimum functionalities. So I also created a bigger library which you can dynamically add. I guess just a second. Yes, you can also check it out on GitHub, and you can fork it and also try further steps with it. Now it also has a documentation if you go to the link, and I can also share this link. Tejas, can you also share that link? So, okay, so you can check how you can use it easily, and this is the CDN for it, and you can just add it to your JavaScript file or HTML file, and then access the neural network class, and then create a data, then train and all that thing. So it is a lightweight, and it can be easily compared in speed with TensorFlow.js, as TensorFlow.js is big and takes some time for computation. But this is just bunch of for loops, and they can run pretty quickly on small data set. So moving on further, we have, okay, adding more feature is that if you take a look at this thing, what we are doing it is in first layer here from here till here. You can see this for layer 1 and this for layer 2, like the output layer and the hidden layer. So what we are doing is we are repeatedly calculating the same things and just passing the data backward. So what you can do, you can optimize this, and you can make a function that will automatically calculate these things or the variables for each layer and will pass the data backward, so that you can create multiple hidden layers dynamically. So that will be the adding more features. And how to access your library. So for accessing a library, what you can do, you can easily host it on GitHub. Like you can upload, suppose in here I have created a repo, and inside the lib folder I have this library, or rather than library, this script file. So here you can see I have this nn.js and nnv0.js. So it is actually a minified version of this file. So you can just minify it easily using the online minifier tool or anything. And what you can do, you can see here I have, I've got this URL. So this URL is very easy. In this name, you can change your GitHub username, and in a light neural networks written here, you can change the repo name, and at the latest is for getting the latest version of the file. As in GitHub, we have commit system. So if you want to get a file for specific commit, you can specify it there. Or if you want to get the file with latest updates, you can just write at the latest and the path of the file, and you will be easily getting access to that file through this JS deliver CD. So if forward, yes, so that was all, and now we can move to wrap up. Wrap up is just like at the end we created this library, and you can easily now create some tools or visualization using this library. And it is very easy. You can create multiple instances, like if you can create arrays of these neural network instances and can train them simultaneously if you want to do something called genetic algorithm and all that. So actually that was the reason why I built this library, as doing genetic algorithm stuffs on TensorFlow was kind of tedious and bit of problematic, because it was very big, and if you create multiple instances of the same objects, then it takes very high computation cost. So for that I wrote this library, and it will easily run on small systems also. So that's all for this library making thing. Now over to you, Tejas.
Okay, can you share the PPT?
This is
Just open. Yeah. Mm, yeah, so that was all. Thank you so much for attending the session, everyone. And let me remind you that all the attendees who have registered for the event will receive a feedback email from DeepLearning.AI team in a while. And after filling that form out, you will receive a discount of 50% on any DeepLearning.AI courses on Coursera for the first month. So keep an eye out on that mail. Also, if you wish to stay connected with us and work on these sessions, maybe you want to talk about some technology or something that you built using your in machine learning and AI field, then you can come up there. So we have a Discord server, and I'll just put the link in the chat. So yeah, this is the link. And yeah, that was it. Now what we saw today was how Suyash built his library for doing some stuff, and it is not it was an intermediary session that if you are just beginning with something like deep learning and AI, then you might have thought that this session was quite heavy or you did not understand some things. And if you already know a few basic things, then it might have been like it might have give you an idea to build your own library and try out some stuff. So you can go on that GitHub repo. It is open source, so you can just fork it and try to make your own stuff with it. And I guess Suresh has put the MIT license, so you can do anything with it and call it your code.
Yes, sure.
Yeah, so just make some changes and try to do something with it. And Also, if you have some suggestions or you want something to be taught in further sessions, like this is our community and we are going to see that what we want, then we can discuss it on Discord as well. So thanks everyone. Thank you once again. Have a great day and let's keep machine learning. Yeah.
So bye bye everyone.
Yeah. Bye everyone.